My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Database Management System as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: what are SQL data types? Give 2 examples. SQL data types with examples. In SQL, data types define the kind of data that can be stored in a table column. They help the database know whether the value is a number, text, date, or something else. Choosing the correct data type saves space and improves performance. 1. Varchar, variable character. Used to store text or words of variable length. Example: create table students. Name varchar 50. Here, name can store up to 50 characters, like Rahul or Asha Sharma. 2. Int, integer. Used to store whole numbers, no decimals. Example: create table students. Age int. Here, age stores numbers like 18, 20, etc. Remember, use varchar for names or addresses. Use int for numbers like marks or IDs. SQL data types make your database organized and efficient, just like choosing the right box to store the right item. Next important short question is: 2. Define integrity constraints in SQL. Integrity constraints in SQL. In SQL, integrity constraints are rules applied to a database to ensure that the data stored is accurate, valid, and reliable. These rules prevent mistakes, like entering a negative age or duplicate roll numbers. They act like guards of the database, checking every entry before it is saved. Common integrity constraints. 1. Primary key makes sure each row in a table is unique. 2. Create table students. 3. Roll no int primary key. 4. Here, no two students can have the same roll no. 5. Not null ensures a column cannot be empty. 6. Name varchar 50 not null. Every student must have a name. Other constraints: unique, check, and foreign key. Example: if a table has a check, age is equal to 18, it won't allow values below 18. Remember, integrity constraints keep the database clean, logical, and error-free, just like school rules maintain order. Next important short question is: 3. What is embedded SQL, dynamic SQL? Embedded SQL and dynamic SQL. 1. Embedded SQL. Embedded SQL means writing SQL commands inside a programming language like C, Java, or Python. It is used when we want a program to directly talk to a database. Example: executive SQL select name from students where roll no is equal to 1. Here, an SQL query is written inside a C program. This makes data access faster and fixed because the query is known at coding time. 2. Dynamic SQL. Dynamic SQL is used when we don't know the query in advance and want to create it at runtime based on user input. Example: execute immediate select asterisk from students where age 20. The query is built and run on the spot. Remember, embedded SQL, fixed queries, written inside programs. Dynamic SQL, flexible queries, created at runtime. Think of embedded SQL like a pre-written recipe and dynamic SQL like cooking based on ingredients available. Next important short question is: 4. Define first normal form, 1NF, with an example. First normal form, 1NF. Definition. A table is in first normal form, 1NF, if all columns contain atomic, indivisible, values and there are no repeating groups or arrays. In simple words, every cell should hold only one value, not a list or multiple values. Why 1NF is needed? 1NF makes data organized, easy to search, and update without confusion. Example, not in 1NF. Student ID name subjects. 101 Rahul Math, Science. 102 Asha English, History. Here, subjects has multiple values in one cell, this violates 1NF. Converted to 1NF. Student ID name subject. 101 Rahul Math. 101 Rahul Science. 102 Asha English. 102 Asha History. Now every cell has a single value. Remember, 1NF is equal to no multivalued columns. It makes your database clean and easy to use, just like keeping one book per shelf. Next important short question is 5. What is a functional dependency in relational database design? Functional dependency in relational database design. A functional dependency, FD, is a relationship between two columns, attributes, in a database table. It means if we know the value of one column, we can uniquely find the value of another column. Definition. For attributes x and y, if x y, then x functionally determines y. This ensures data consistency and helps in database normalization. Example. Roll no name age. 101 Rahul 18. 102 Asha 19. Here, roll no name, age because knowing a student's roll no uniquely identifies their name and age. But name roll no is not always true, as two students might share the same name. Why important? Helps remove redundancy. Ensures data accuracy. Forms the basis of normalization, 1NF, 2NF, etc. Remember, think of functional dependency like a school ID card. If you have the ID, you can find all details about the student. Next unit 3. Long questions. First important long question is explain SQL schemas and advanced SQL features with examples. SQL schemas and advanced SQL features. 1. SQL schemas. A schema is like a blueprint of a database. It defines how data is organized, tables, views, indexes, triggers, and relationships between them. Schemas help keep data organized and secure by grouping related objects. Example. Create schema school. Create table school.students. Roll no int primary key. Name varchar 50. Age int. Here, school is a schema containing a student's table. This makes it easier to manage large databases, just like separate folders in a computer. 2. Advanced SQL features. 1. Views. A virtual table created from an SQL query. Create view student names as. Select name from school.students. This simplifies complex queries and improves security by hiding sensitive data. 2. Stored procedures. Reusable SQL programs stored in the database. Create procedure get all students as. Select asterisk from students. It saves time and improves efficiency. 3. Triggers. Automatic actions when events happen, like insert update. Create trigger age check. Before insert on students. For each row. When new dot age 5. Begin. Raise error age too low. End. This ensures data rules are followed. 4. Indexes. Like a book index, it speeds up searches in a table. Create index IDX_name on student's name. Why important? Schemas organize data. Views and stored procedures simplify coding. Triggers enforce rules automatically. Indexes make searching fast. Easy tip to remember. Think of a schema as a school building, database, classrooms as tables, and views, triggers, and indexes as tools that make the school run smoothly. Next important long question is: 2. Discuss authorization in SQL and how it is implemented. Authorization in SQL and its implementation. Definition. In SQL, authorization means giving specific permissions to users so they can only do what they are allowed to do in a database. It is like giving keys to different rooms in a building. Not everyone gets access to every room. Authorization helps keep data safe and secure. Types of authorization. 1. Read. Select allows viewing data but not changing it. 2. Insert allows adding new records. 3. Update allows modifying existing records. 4. Delete allows removing data. 5. All privileges, full control over a table or database. How it's implemented. Authorization in SQL is implemented using commands like grant and revoke. Examples. 1. Grant permission. Grant select, insert on students to Rahul. Rahul can now view and add data to the students table but cannot delete or update it. 2. Revoke permission. Revoke insert on students from Rahul. Now Rahul can only view data, not add new records. User roles. Admins can create roles, like teacher, clerk, and assign permissions. Create role teacher. Grant select, update on students to teacher. This makes managing many users easy. Why important? Protects sensitive data, like salaries or exam results. Prevents accidental or unauthorized changes. Keeps the database organized and secure. Easy tip to remember. Think of authorization as a library card system. A student card lets you only borrow books, select. A librarian card lets you add or remove books, insert, delete. This keeps everything safe. Next important long question is: 3. Explain recursive queries, functions, and procedural constructs in SQL. Recursive queries, functions, and procedural constructs in SQL. SQL has advanced tools to solve complex problems, automate tasks, and make databases more powerful. Let's break them down. 1. Recursive queries. A recursive query is a query that refers to itself. It is mainly used to work with hierarchical data, like family trees, employee structures. We use common table expressions, CTEs, with recursive. Example. With recursive employee hierarchy as: select EMP-ID, name, manager ID from employees, where manager ID is null. Union. Select E.EMP-ID, E.name, E.manager ID. From employees E. Join employee hierarchy on E.manager ID is equal to E.emp ID. Select asterisk from employee hierarchy. This finds employees and their reporting structure. 2. Functions in SQL. Functions are reusable programs that return a single value. Example. Create function getAge, birth date, date. Returns int. As return datedef, year, birth date, get date. Calling getAge, 1st January 2005, returns the person's age. 3. Procedural constructs. SQL procedural constructs let you write step-by-step logic like in programming languages. Variables store data temporarily. Loops repeat tasks. Conditions run code based on if-else. Example. Declare @count int is equal to 1. While @count happy smiley 5. Begin. Print hello. Set @count is equal to @count plus 1. End. This prints hello 5 times. Why important? Recursive queries handle hierarchies easily. Functions make code clean and reusable. Procedural constructs automate repetitive tasks. Easy tip. Think of recursive queries as a family tree, functions as a calculator button, and procedural constructs as recipe steps, all making SQL more powerful and easier to manage. Next important long question is 4. Describe decomposition using functional dependencies with suitable examples. Decomposition using functional dependencies. Definition. In database design, decomposition means breaking a big table into smaller tables to remove redundancy, duplicate data, and maintain accuracy. Functional dependencies, FDs, help us decide how to split a table while keeping all relationships intact. Goal: make the database organized, consistent, and easy to update. Why decompose a table? To remove anomalies, insertion, update, deletion errors. To ensure data integrity. To follow normalization rules 1NF, 2NF, 3NF, BCNF. Example, before decomposition. Role no name course instructor. 101 Rahul DBMS Mr. Kumar. 101 Rahul Networks Ms. Asha. Here, role no name and course instructor. Problem: student's name is repeated. If we change the name or instructor, we must update multiple rows. After decomposition. 1. Student table. Role no name. 101 Rahul. 2. Course table. Course instructor. DBMS Mr. Kumar. Networks Ms. Asha. 3. Enrollment table. Role no course. 101 DBMS. 101 networks. Now data is clean, with no unnecessary repetition. Benefits: easier updates and inserts. No duplication of names or instructors. FDs guide which attributes go together. Easy tip to remember. Think of decomposition like separating books by subject in a library, easier to manage and find information. Next important long question is 5. Discuss the features of good relational database design and importance of atomic domains. Features of good relational database design and atomic domains. A good relational database design makes data storage organized, efficient, and easy to manage. It prevents duplication, ensures data accuracy, and speeds up queries. Features of good database design. 1. Normalization. Tables should follow rules 1NF, 2NF, 3NF, BCNF to remove redundancy. 2. Clear primary keys. Every table must have a unique identifier, like roll no, for each record. 3. Relationships. Use foreign keys to connect tables, ensuring data consistency. 4. Integrity constraints. Apply rules like not null, check, and unique to prevent wrong data entry. 5. Simplicity and flexibility. Design should be easy to understand and adaptable to future changes. Atomic domains. An atomic domain means each column in a table should hold a single, indivisible value, not lists or multiple values. Example: wrong design. Student ID subjects. 101 Math, science. This violates atomicity because one cell has two subjects. Correct design, atomic. Student ID subject. 101 math. 101 science. Now, data is atomic and easy to search or update. Why important? Reduces duplication and update errors. Makes querying faster, example, easy to find students in math. Forms the foundation of normalization and efficient design. Easy tip to remember. Think of atomic domains like packing one chocolate per wrapper, simple, clear, and easy to handle.